Hi, I'm Sarah. I'm a PhD student in statistics at the School of Maths and Stats here at the University of Sydney, and I'm also a postgraduate teaching fellow with the school as well. So the research I do is statistical machine learning, and we are mainly looking at developing mathematical methods for high-dimensional data. The reason why my research is important is that in the age of data science and big data, we have more data than ever before in order to make predictions and inform our decisions. And so in particular, I work with health data, and it's very important to make predictions and inform decisions about the treatments for patients and their prognosis. So one data set I use is the first one I came across in my studies, which was a high-dimensional melanoma data set. So we had 47 patients with gene expression measurements for all their genes, and we're interested in seeing how we could predict their prognosis or their survival time just purely from their gene expression measurements. So my favorite data visualization for this data set is a density plot. And so, for example, we've got density plots for two genes, and we can clearly see that we have differential spread between the classes. So classes 1 and 2, poor prognosis and not so good prognosis, and class 3, the orange class, is our good prognosis group. So we can see a big spike in expression for the good prognosis group for a particular gene, but for the poor and middle prognosis groups, we see that it's not quite as expressed. It's still expressed, but it's not quite as expressed, and it's a really interesting thing to see with the data. The aspect of data that's most important for my research is accurately modeling the structure of the data. So with all our statistical machine learning methods, we are making assumptions about how the data is spread. And so for this particular data set, we were assuming that each feature was normally distributed. And so that's a pretty big assumption to make. And with different data sets come with different assumptions. And if you don't meet those assumptions, your modeling isn't valid at all. I see data science having a massive role in my research now in the future. Statistical modeling used to be quite pen and paper, minimal visualizations, but now it's increasingly important to make sure that your visualizations and your communication tools are effective in order to communicate your results with both your peers and also the general public. So I see data science, the ability to work with data effectively, increasingly important in statistics, because if you can't work with the data, you can't even model it to begin with. If you realize that you want to work in data science, think about the other units you can take as well. So my biggest regret doing statistics was not doing more maths than I could have. So I did a bit of maths units, but if you want to go into statistical machine learning and develop models, mathematics is an important part for that. And also I wish I did more computer science units to improve my coding. So coding, as we know, is very important, using R as well. And my second piece of advice is just to never give up. So coding can be a bit daunting at first. I remember, hating it when my code wouldn't work the first time, but I'm learning to surf, for example, right now, and most of the time when you first start off, you don't make the wave. But the same thing with coding, the first time you try, not going to work, but the rush you get when you finally get the wave, and it's the same thing when you're doing coding, the rush you get when your code finally executes with no errors is just worth all the effort you put into it.